Good morning, everybody. Myself, Acharya Vishvendra, and today I shall be speaking about light, uh, certain theories of light as a ray, as a wave, and as a photon. So, let's begin with things. So, basically, today I'm going to speak about optics, so which is about light. So, light can be studied as a ray, as a wave, or as a quanta or photon. So, light as a ray means light as a particle, which was proposed in corpuscular theory of light, proposed by Descartes and further developed by Sir Isaac Newton in his book Optics. Behavior of light as a wave. So, wave or energy, we can say that. So, it was proposed by Christian Huygens and it was experimentally proved by Thomas Young in 1801. Third dimension of light is as a photon or quanta, which was proposed by Albert Einstein and Max Planck in form of quantum theory of light, which explained photoelectric effect in 1905, and for that Albert Einstein was given Nobel Prize in 1921. So these are the three dimensions of light: light as a ray, light as a wave, or light as a photon or quanta. Although there is a similarity between light as a ray and light as a quanta, because light as a ray means that any source is emitting certain particles which are called the corpuscles. And in quantum theory of light, light is also made up of discrete packets of energy. Now, there is a reminiscence between packet and the particle. So we can say that ray and photon or quanta have similarity, or in a way, light is both a particle as well as a wave. Now, if we see what is a wave, so we say that wave is a disturbance. What disturbance? The next question comes. The disturbance may be displacement of particles or the electric and magnetic fields. But here is the question that what is the wave in that disturbance? Actually, the factor which is causing the disturbance, the energy basically, is the wave over here. Because let's elaborate it with the help of an example. Suppose there is a river, we drop a pebble into it. So we can see that waves will be produced in the river, and we will see circular waves to be transferred in the river, which are in the form of concentric circles and which obviously keeps on moving up to certain time. Now the question here is, what is wave over here? So if you see the picture of the water surface, just before dropping the pebble and after dropping the pebble, then before dropping the pebble all the particles were in the plane, but when you drop a stone, then there is a transfer of energy to the water molecules where the pebble strikes. Because of that, the water molecule starts vibrating, and since there is surface tension between water molecules existing at the surface, because of that surface tension, the impact or the energy got transferred to other water particles, which then started oscillating up and down. perpendicular to the surface, and that entire disturbance is transferred from one concentric layer of water molecules to the other. So here the disturbance is oscillation of water molecules perpendicular to the free surface. So to whom we are referring to as the wave? Who is the wave here? So it is the energy transferred which causes particles to uh, you know respond in a certain way. That stimulus, that force, that energy is the wave over here. So that is the fundamental difference between wave and particle. So let's now start with study of light as a ray and wave, that when it behaves as a ray and when it behaves as a wave. So light behaves as a ray, or it travels in a straight line, or it is made up of particles when size of the obstacle is very large as compared to the wavelength of the light. Then it seems like light travels in a straight line and behave as a ray. You can see the shadow formed when something is put in the path of uh, light. You must have done some experiments in class 9th in which you observe a candle from a pinhole, and if something is placed between the pinhole and the candle, then you don't see the flame of the candle, which proves that the light travels in a straight line as per the example is concerned. But if you decrease the size of the aperture, then something phenomenal happen. There is a bending of light and departure from the straight line behavior. As you must have seen that light bends at the corner, and that bending uh, can be explained by the wave nature of light. So light behaves as a wave when size of obstacle is comparable to the wavelength of the light. We can demonstrate using these two examples. Now let's start with the ray. What is a ray? So ray is a directed line segment which shows the direction of propagation of light. These are our three types: converging rays, diverging rays, parallel rays. For virtual object and real image, we have converging rays. Converging means distance between them decreases as we move ahead. Then diverging rays. Diverging rays corresponds to real object and virtual image. And parallel rays, which corresponds to object and image at infinity. Now there is concept of object in optics. So object is the point of intersection of incident rays. Object may be real or virtual. For real object we have diverging rays. For virtual object we have converging rays. Next we have image. So image is the point of intersection of reflected or refracted rays. They also may be real or virtual. Real image means converging rays and virtual image means diverging rays. Now let's consider image for mirror and lens. As per mirror is concerned, outside mirror if object or image are there, it is called real, and inside mirror it is the virtual. So everything that you see inside the mirror is virtual. So in case of mirror it's very simple. In case of lens it's a bit complex. So let's analyze object and image. So as per lens is concerned, object is if object is composed of diverging rays, it is real, and converging ray is virtual. Whereas image image is concerned, we assume that here object is real. So if object and image are on the same side of lens, the image is virtual, while if these are on opposite side of the lens, the image is real. And for virtual object, we can use the concept of converging and diverging rays. If refracted rays are converging, then image is real, and if it is diverging, then image is virtual. So using these three concepts, we can solve questions based on real and virtual images. So these are the basic concepts, basic terminologies related to the optics itself. And optics itself is a very scoring, you can say, branch of physics. If you are done with the basics, then it's uh, very easy to score in optics itself. So these videos are just made to make sure that you grasp the basics of the very fundamental things concerned with here you say rays, their types, their categories, object, image, their classification, when they are real, when they are virtual. So I think these will help you in scoring good in your exams. Thank you and have a nice day.